By the way, we are going to spend at least 2 hours, including lab exercises, on this. So that is that much, I mean, it's that important. Okay, at least 2 hours. All right, abstract class and Java interface. As you can see, from the importance scale, this is extremely important. In fact, the most important concept of all. So we are going to learn what an abstract method is and what an abstract class is, and then we are going to learn what an interface is. We have exposed, we got exposed yesterday, when we do event handling. There was actually an interface and implementation, right? Okay, and then we'll talk about why you want to use interface. Okay, so this is very important that you understand why you want to use interface. Okay. Then we'll talk about interface as a type. Again, it's very important. And then we'll compare interface against class. And we'll see how we can define an interface and how we can implement that interface. And we'll talk about how a class can implement multiple interfaces. And we'll also talk about interfaces inheritance. Interfaces can have inheritance among themselves. Then we'll talk about rewriting interface. Okay, so quite a bit of topics to talk about. So let's talk about abstract method and abstract class first. So what is an abstract method? Abstract method is a method that does not have code block, meaning it doesn't have implementation code. Okay, so in order to declare an abstract method, you are going to use abstract keyword without any code block. Okay, meaning without any curly brace like this. So if you want to define a method in a class in an abstract fashion, meaning abstract method, basically you are going to say abstract and then return type and the name of the method, and then parentheses with some arguments. We don't have any arguments in this particular example, and that's it. You end it with semicolon. As you can see, there is no body of code, meaning there is no code block. Okay, it doesn't provide any implementation. So this is called abstract method declaration. So continuation of now. So that's an abstract method declaration in a class. Now, what is an abstract class? Abstract class is a class that contains one or more abstract methods. Okay, so we'll see an example in a few seconds. So let me repeat. An abstract class is a class that contains one or more abstract methods like this. Okay? And the way that you are going to declare abstract class is that you have to say that using abstract keyword. So if you declare your class as an abstract class but don't have any abstract method, then that's a compile error. Okay? Alright, so we'll see an example in a few seconds, so don't worry about it if you don't understand what I'm talking about. An abstract class cannot be instantiated. So if you try to create an object instance from your abstract class using new keyword, this is a compile error. Okay? Now, the abstract method is basically just defining the name of the method and set of parameters, right? So there has to be another class, and we are going to call it concrete class, which provides the implementation of all those abstract methods. So this concrete class has to implement all abstract methods. Okay, it cannot just selectively implement abstract method. It has to implement all abstract methods. Okay, so concrete class has to implement all abstract methods of abstract class in order to be used for instantiation. So this concrete class could be used to create an object instance. Okay, again, it will result in a compile error if not all abstract methods are implemented in this concrete class. Now, concrete class will use extends keyword to extend abstract class. Okay, all right. So maybe you might want to, you probably get confused. What are you talking about? So let's see an example. So this is the definition of abstract class. So abstract class has to be declared with abstract keyword. Okay, So like here, public abstract class and living thing. So when you declare a class as an abstract class using this abstract keyword, okay, you can have two kinds of methods. You can have a regular methods. So these are regular methods with code block. Okay, so this is no different from others that we have seen so far. However, it has to have at least one or more abstract method. So here we define an abstract method called walk by using abstract keyword. Okay? Now, so this is an example of abstract class that contains abstract method. You can have a multiple abstract methods, of course. Okay? So this abstract method has to be implemented by concrete class. Alright, so let's talk about concrete class. So here we are creating a concrete class called the human, which extends living thing abstract class, and it has to provide implementation of all abstract methods of this abstract class. So in this example, we have only one abstract method in living thing abstract class, so it will provide implementation of this walk abstract method of living thing here. So this is the body of code that it provides for the walk abstract method defined in living thing. Okay? Alright, so let me just repeat one more time. So this is abstract class that contains a single abstract method called the walk, and that abstract method has to be implemented by a concrete implementation class, and then that implementation should provide a code block for that abstract method for all abstract method. Okay, here we have only one. Okay. Okay, so you might want to ask, so what is a big deal? So why you want to create abstract class and abstract methods and things like this? Okay. So the reason you want to create an abstract class which contains abstract method is when there are cases where you have multiple subclasses, so in this case concrete subclasses, to provide different implementation for similar role. Okay, so in fact this is polymorphic behavior. Okay, so basically we have walk. Okay, this is a walk behavior, but the actual implementation could be different between human and a monkey or a bird, right? Okay, so this is again to provide polymorphic behavior. Again, I'm not going to talk about what polymorphic behavior in detail for now, because we're going to spend quite a bit of time talking about that later on. For now, just focus on the syntax. So you could have multiple subclasses, meaning multiple concrete subclasses, extending that same abstract class like a living thing, but provide different implementation for that the abstract method. Okay, so again, this human subclass, concrete class, will provide different implementation, human walks, and if you create a monkey that extends living thing abstract class, the walk method of that monkey concrete class will have a different implementation. Maybe it will say monkey walks or something like that. So you use abstract classes to define broad type of behaviors at the top of object-oriented programming class hierarchy, in this case living thing, and then use subclasses to provide different implementations. Okay, so I acknowledge that I have not really provide very concrete reasons why you want to use abstract method and abstract class, but for now just think of it as a basically the reason is because we want to have some polymorphic behavior. Okay, so let's do exercise 1. So let's go to the lab documentation. So we are going to build an application in which we are going to have a multiple classes. Okay. So here, oh, I'm actually looking at the wrong one. Sorry about that. Yeah, I should actually look into interface. Okay, so exercise 1 is abstract class. So here we are going to build and run the application that use abstract class, and then exercise 1.2, again, feel free to run this one, but we're not going to actually work on this. So just do 1.1. Okay, so we are going to create a new project. So this is actually basically using the same classes that we have seen in the slide. So we're going to define living thing, okay, in this package. So living thing has this walk abstract method. Okay, so same thing we have seen in the slide. Okay, so I'm going to move on, and then we are going to define a human concrete class, which extends living thing abstract class. So it has to provide this implementation of walk, the abstract method. If you just comment this out, you will experience a compile error. So try that. Okay, see whether you get compile error or not. The compiler error will actually say, you are extending abstract class, which contains an abstract method, and you haven't provided implementation. Okay, if you comment this out. Okay, so this is implementation for walk abstract method, for living thing abstract method. Now we are going to provide another concrete implementation. This time is monkey. So monkey has its own implementation of walk abstract method. So it, as we actually have a very simple implementation. So we are going to just to say monkey also walks. And then we are going to create a main method. Here we define, so this is the case that we created human object, okay, and then we assign to a human type variable. So of course we should be able to walk here, okay, because human provide the walk implementation. So it should say human walks. Okay, now we are going to so this is actually typing as we learned. Okay, in inheritance as well. So you can assign the human object to this living thing type. Okay, and then you can call walk method of living thing one object. So this living thing one object is a variable whose type is living thing, but is actually pointing to human object. Okay, all right. Now, because it's pointing to the human object, it will know what walk method is going to invoke. Okay, so that walk method is from human object. Okay, now we create the monkey object this time, and then we are assigning to living thing 2. Okay, and living thing 2, which is a living thing type, and we can also call walk. So this is the polymorphic behavior. So depending on what object is actually pointing to, even though this living thing 1 and living thing 2, they are the type of living thing, because it's actually pointing to a particular concrete object instance, in this case human and in this case monkey. When walk method is invoked, it knows which object instances walk method needs to be invoked. So this one will invoke human object walk method, and this will invoke the monkey version of it. So that is in fact polymorphic behavior. Okay, all right. So we can display the data from human 1 and living thing 1. So the get name and get name, so this is not even abstract method, so you should be able to call this method. Okay, now you can compare a human 1 object and living thing 1 object. So when you compare object using this 2 equal sign, that means whether these 2 variables are pointing to a same object instance, and that should be the case, and it should return true. Okay. Also, you can actually experience some compile error. So try to create an object instance from the abstract class. Okay, and it will result in compile error. Okay. Now, I want you to do your own exercise. So I'm actually giving you guys time to do your own exercise as well. So here you're going to create another abstract method in living thing. That abstract method is going to be called dance. And then provide a concrete method of this dance abstract method in human and monkey. You just print things out, okay? And then modify the main.java to invoke main method as we've done, the walk method, okay? So I'm going to give you about 15 minutes. So we are going to have a lunchtime at 1. So we are going to be back. I'm going to add 15 minutes plus 30 minutes. So we will be back 35 after the hour. Okay? All right, guys. Let's resume. And interface. So what is an interface? Interface is basically a collection of abstract methods. So in interface, all methods are abstract methods. So we have learned the abstract class and abstract method, right? So in abstract class, you have only a subset of those methods are abstract methods, while in interface, every single method is an abstract method. So basically, you are going to define a set of abstract methods without the body, code block, or implementation of the methods. Now, because in interface, every method is an abstract method, you don't have to specify abstract modifier for those methods, even though you could, okay? But you don't have to. Now, as like in abstract class, a concrete class must implement the interface. Okay, what that means is that all abstract methods of that interface need to be implemented. Okay, now how are you going to define an interface? You are going to use interface modifier to the declaration. So let's see an example in a few seconds. Now, so what is an interface for? It defines a public way of specifying behaviors of classes. What it means is that the user of the interface and the provider of the interface. So here, user of the interface is the one that uses that interface, and provider is the implementation class. Okay, the contract between user of the interface and implementation is defined in a form of interface. And we'll see why that is important in a few seconds, in a few minutes. So this is an example of relation interface. So you are going to say public, and then you are going to use interface keyword. Then you give a name, relation. And then, as you can see, you are going to have a set of abstract methods. So here it has 3 abstract methods: is greater, is less, or is equal. And you can tell these are abstract methods because it doesn't have any code block. Okay, so this interface needs to be implemented by implementation before object can be instantiated, or before object can be created. This is another example of operate car. So basically, you could have a set of methods like a turn, change lane, or signal turn, or get radar front, get radar rear, or something like that. An interface could have a constant declaration, but don't worry about it. Just for now, think of interface as a set of abstract methods. Okay. Okay, so why interface is important? Okay, so again, these are very critical concepts you need to understand. Okay, so make sure I pay attention to this concept, and I really want you guys to get the good understanding on these aspects. Okay, and in fact, we'll spend quite a bit of time doing lab exercises on this. So there are few reasons. There are in fact 3 important reasons why usage of interface is important. You can define an interface to reveal the contract of programming API, okay, without revealing its implementation. So this is in fact the concept of encapsulation we talked about on and off, right? Meaning the implementation details are not visible, meaning implementation details are hidden from the user. Okay, the user will just use interface, and the provider of that interface will provide implementation, but implementation can change without affecting the caller of the interface. Okay, because the caller or user of that interface does not care how that interface is implemented. So caller in fact does not need the compilation, does not need the implementation class at compile time. It only needs interface. So in fact this is in fact the difference from like a class is C programming. In C programming you have to have a concrete class. In Java, because of the functionality of interface, because of the feature of interface, you do not need the concrete implementation class at compile time. Only thing you need is just interface. So this has several advantages. In a reasonably good size application development, there could be in fact several groups or several people, multiple people are working in parallel, okay? And only thing they have to agree upon is basically an interface. You know, if each person is working on different functionality, only thing they have to agree upon in the beginning is just interface. They don't have to agree upon the implementation. Okay, so they can work in parallel. Now later on, during runtime, object instance gets created from implementation class of that interface, and then it will be associated with the interface type. And I'll talk about what it means, associated with interface type, in a few minutes in a detail. Okay. So this is reason number one, encapsulation. Okay, meaning implementation detail is hidden from the user of that interface, and they can work together in parallel without having implementation class. Okay, reason number two, you could have unrelated classes to implement similar methods using interface. So let me give you an example. By the way, one thing I have not emphasized enough in Java inheritance is that a Java class can inherit from a single parent. It cannot have inheritance from multiple parents. So in Java, a class can have only a single parent class. Okay. So I think LP was asking, I think someone else was asking, why Java does not support multiple inheritance? Okay, multiple inheritance actually lets you have a different behavior from different parent classes, but it has some side effect that are undesirable. I'm not going to actually go into that. So Java designer James Gosling, when he designed Java, he decided not to support multiple inheritance because of those side problems. Now, in order to simulate that multiple parent, you could actually use, in fact, the multiple interfaces. So in Java, you could have a single parent class, meaning you can extend a single parent. However, you could have a multiple interfaces. Okay. Yeah, actually that's actually the reason number two. Okay, so I was actually explaining reason number the multiple interfaces. That's reason number three. I'm actually talking about reason number two. So sorry about that. Maybe I confuse you guys a little bit. So here, reason number two is that to have unrelated classes implement similar methods. Okay, so let's say there are two different classes, like a line class and myInteger class. Okay. And they are not really related in inheritance, meaning line is not a parent or the ancestor of myInteger, or vice versa. myInteger has nothing to do with the line. Okay. However, you want to impose some similar behavior. For example, check is greater, or check is less, or check is equal. If you want to actually impose this comparison methods to both of these, the unrelated classes, you could using interface. Okay, so basically what you can do is that you are going to define comparison interface, and then let the align and line manager, my manager, to implement this comparison interface. So you are basically having these unrelated classes to implement the same interface. You're actually imposing similar behavior to unrelated classes, meaning unrelated through inheritance. Okay, reason number 3, that's what I was talking about, to model multiple inheritance. So you want to impose multiple sets of behavior to your class. Okay, so you could actually have multiple interfaces, and a class can implement multiple interfaces while it can extend only one single parent class. Okay. Now, don't worry about it if you have not understand what I just talked about. Okay, so we are going to actually do hands-on lab exercises to define all these features. Okay, so don't worry about if you don't understand these reasons. We'll get back to this again multiple times. Okay. Now, so we have learned abstract class that contains some abstract methods, and then we also have learned interface. Okay, so they seems to be behaving somewhat similarly. They actually have abstract methods. So what are the differences? So differences are, in interface, every single method is an abstract method, while in abstract class you have a subset of those methods are abstract methods, and rest of them are regular methods. Okay. All right. And also in terms of syntax, abstract methods of abstract class must be must have abstract modifier, while in interface those methods do not have to have abstract modifier. Okay. Interfaces have no direct inheritance relationship with any particular class. Okay, so they are defined independently. So you cannot have parent and child relationship with an interface with another class. Okay. However, interfaces themselves can have inheritance relationship. Okay, so we'll talk about that later. Okay. However, abstract class can have a parent class. So abstract class, yeah, I'm going to skip that part because they might actually confuse it a little bit. So for now, you can think of this as second aspect. Interface cannot have parent and child relationship with another class. Okay, so that's basically what I meant to say on the second bullet. An interface can define constants, while abstract class can have fields. Abstract class is like a semi-regular class. Okay, so it could have fields and it could have regular methods. Okay. Okay, so next point, interface as a type. So this is again very critical concept. Okay, so we have actually learned class as a type. Right? So you could have a superclass variable that is assigned with an object instance, right? So now we can use interface as a type as well. Okay, so let's see examples of this. So when you define a new interface, you are defining a new reference type. Okay, so you can use interface, in fact, any place that you can use a class as a reference type. Okay, so example is like this. Here we are using person class as a reference type. Okay, meaning, by the way, when I'm saying reference type, I'm talking about variable type. Okay, so this is the example that we have seen so far all along. Basically, we were using class, like a person class, as a reference type, or we used a superclass of a person, like object in this case, as a reference type. However, you can use interface as a reference type as well. So here, suppose if we have defined the person interface, and person is the implementation of person interface, then we can actually use person interface as a reference type. Okay, so any place that you have this person as a reference type, you could use instead interface type as a reference type. Okay, so I create a person object instance, and then I can assign to a person interface type, and I can create the person object and assign to person interface type directly like this. Okay, so here the first line, class is used as a reference type. Here person interface is used as a reference type, and here interface is used as a reference type. Okay, all right. Okay, so if you define a reference variable whose type is an interface, any object you assign must be an instance of a class that implements the class. So here, when you are assigning, for example, let's take a look at the last line here. When you are assigning an object instance to a reference type, okay, the actual class has to be implementation class of this interface type. Okay, so that's what this second bullet is all about. All right. Another case of you are using interface as a type is the parameter passing. So here you are passing person object as a reference type here, right? Now you can also use interface as a reference type when you're passing a parameter or an argument like this. Okay? Alright, so let's talk about interface versus class. So the commonality is that both interface and class define methods. Okay? And interface and classes are both types. So again, as we learned before, you were able to use class as a reference type for variable type. Okay? And now you can do the same thing with interface. You can have interface type like this as a reference type. In fact, when you have a choice between using interface type versus a class as a reference type, usage of interface type is recommended. The reason is this. As I said before, if you're using interface type like this, okay, then you could actually compile the code even if there is no implementation. Okay, here if you're using person as a reference type like here, then you have to have a person implementation class. Okay, so again, in large organizations where a large application is being built, implementation classes are not always readily available, right? So in fact, multiple people want to develop application in parallel. So in that case, what they want to do is just define an interface and they can just continue work. All they want is an interface to kind of move ahead, right? And then later on, when the real implementation is available, they can actually use that implementation. Okay, and in again, development environment, the different production environment. So I'm going to just skip that aspect. Okay, so usage of interface is highly recommended as a reference type against the usage of class type as a reference type. Okay, so I want you to think about this aspect. Okay, because in this case you have to have an implementation class, and in many cases that implementation class might not be available. Okay, and also implementation change in person class could directly affect this class. I'm going to skip this aspect. For now, just talk about focus on compile time. Usage of interface is possible, while usage of the implementation class is not possible. In terms of differences, the methods of interface are all abstract methods, while the methods in the class, regular class, they are all concrete methods, meaning they have code block, meaning body of code. Okay, just like abstract class, you cannot create an instance from an interface. So if you try to create the object instance from interface, you will experience compile error. Okay, so typically what you do is you are going to create an object instance of the from the implementation class of the interface, and then you assign to the reference type of interface reference type like this. Okay, so we have seen the example of defining interface already. The syntax, just to go over the syntax one more time, you are going to use interface keyword. Okay, so you start with the public and then use the interface keyword, and then you provide the name of the interface, and then you are going to provide a set of methods. Okay, so those are abstract methods. So again, this is an example that we have seen before, right? So we define relation interface, and it does have 3 abstract methods. Okay. So basically, when you want to have this kind of relational behavior to multiple implementation classes, at that point you could actually define this interface, relation interface, and then you are going to ask these the classes to implement this relation interface. Okay, so in terms of implementing interface, the keyword is this. So this line is the concrete class implementing relation interface. So in this case, concrete class implements interface. In this case, relation. So this line, concrete class, has to implement all methods of relational interface. So it should actually implement these is greater, is less, or is equal. If concrete implementation class did not implement all abstract methods of that interface, then that's a compile error. Okay, so this is an example when you are compiling an compiling the code, compiling the implementation class that has not implement all abstract method. Okay, so line is not abstract, 9 is not abstract, and does not override abstract. But yes, the error message is a little bit cryptic, but basically when you are missing, when your implementation class forgot to implement one of those, the methods of interface, this is the compile error that you're going to get. Okay, so this is very important concept, as I said before. So we'll actually do plenty of lab exercise on this. So let's go to exercise 2. Okay, so in this case we are going to try Java interface as a type, and then we are going to use relational Java interface. Okay, so here we are going to create so here we are going to create person interface. Okay, and the person interface is basically has 2 methods. Okay, so it does have a compute total wealth method, and then it does have a get name method. Okay, so as you can see, it doesn't have any body of code. Okay, it just has the method signature. Okay, so that's person interface. Now we are going to implement implementation class. So here we are going to create person class which implements person interface. Okay, so it could have a constructor method, and now it has to implement these 2 abstract methods of that interface. So compute total wealth, and then the get name. Okay, so you provide whatever logic here. So it's basically we are the adding cash, saving, and retirement fund, and then in return int type, and here we are just get the name of the person and return. Okay, now here we are going to actually write the main code. So here here we created person object instance. Okay, and now we assign to a person type. Okay, so this is what we have been doing all along. Okay, but when you are using interface and implementation class, instead of this, it is highly recommended that you are using this notation, so that on the left you are going to use an interface. Okay, and then so here we are basically assigning this object, but you could actually have, you create the person object directly and then assign it to right here directly. Okay. Okay, so here now so basically you can use this interface type in any place that you can use this person interface type as a reference type. Okay, so here we are just displaying the get name and compute total wealth. Okay, and so here we are actually using person object. Here we are using the person interface 1 type object. Okay, so this one is actually pointing to the same, this one and this one, they're actually pointing to the same person object of this, right? Okay, and in fact you can compare the person 1 object and person interface 1 object. these are variables. They point to the same person object. So when you compare, it should return true. Okay, so this boolean should be true. Okay. All right, now here, this is an example that we are directly creating person object and assign to a person interface type. Okay, and again, we can actually call the names. Get name and compute total wealth like this. Okay. All right, so exercise 2.2 is we are going to build a Java application in which we are going to use that interface, a relation interface that we have seen. Okay, so relation interface is like this with 3 different abstract methods: is greater, or is less, or is equal. Okay, it's accepting object. Okay, type. And then we are going to create concrete class, in this case line, that implements this interface type. Okay, and so basically it has to provide the implementation of is greater and is less or is equal. Okay, so don't worry about this logic here. Okay, so the key point is that the way that you are going to provide is greater logic for line implementation versus the next one, yeah, I think we could actually build another one. For example, we could have like a circle. We could have the circle class. We could have a circle class that implements this relational interface, and the way that is greater is being implemented for circle implementation class is going to be different. The logic is going to be different, right? Okay. And here we actually created line object, and now we are actually assigning to relational interface type like this. Okay. All right. Now we can certainly check whether the so we actually define line 1 and line 2. Okay, so which is reference type is line class. Okay, and we can certainly use is greater and is equal method from this the line type. Okay, however, we are going to actually assign the new line object into a relation interface reference type. Okay, so for B3 we can actually do the same thing. We can call the method that are defined in relation interface. So here in line 3 we can actually call is equal. Okay, that is equal is actually being from this relation interface, but the actual implementation that is being used is line object. Okay. Okay. Now this is a case that will generate the compile error. So here, if you try to call, in this case, line 3 is not the type of. So line 3 is type of relation interface. So you can call only the methods in this interface. You cannot call anything else. So the getLength method, okay, getLength method is from the line implementation class here, right? This is not visible from the interface type. So relation interface does not know anything about this method, which is coming from the line. So when you try to call a method that is not visible in this type, relation interface type, you are going to experience compile error. Okay, so I want you to actually think about this. All right, so I'm going to give you 15 minutes, okay, to exercise this. I just added this slide. So which one to use? Person class versus person interface and person input class. So suppose if you are providing a class that will be used by other people. So you have 2 choices. You can provide, for example, just a single class, like let's assume person class. Or you could actually provide person interface and person input class. So person input class will be implementation of person interface. So basically it's very easy, in fact, to convert person class to person interface and person input, and vice versa. All you have to do is just taking the methods of this person class and make it as a person interface, and then you're going to actually provide implementation of that class that provide the code block. So the conversion from a single class to the combination of interface and person and vice versa is very simple. So when you are providing a class that will be used by other people, or even if you're working alone, you could in fact have some classes using other classes, right? So you have a choice of these two, providing just person class and or a combination of these two. So when to use this? In general, when the class is being used by multiple people and the implementation could actually change often, then you want to actually take option 2, meaning you want to provide it as interface and implementation combination. Okay? So the benefit of that is, again, other people just do need interface for compilation. And because the separation of the contract and implementation, so this is important aspect, by having interface and implementation as a separate piece, okay, the contract is defined between user and the implementer, meaning implementation class. Implementation class can change without affecting the user of that interface. Okay, so when that interface, when the class is being used, so again, just to repeat, when the class actually has a possibility of being used often, even in the single user case, or if it's used by other people, definitely you should make it as a combination of person interface and implementation. If the class is being used very rarely and do not change that often, then you could actually provide it as a class. Okay? Alright, so this is actually pretty important aspect. And in fact, the many libraries that you find out there, they will typically provide library in the form of interface and implementation combination. Okay, because of the benefits I just talked about. Okay, all right. So let's move on to the next topic: implementing multiple interfaces. So, as we talked about, concrete class can only extend one parent class through inheritance relationship. Okay, so you can extend just one parent class. However, a class can implement multiple interfaces. Okay, so as I said before, Java programming language does not permit multiple inheritance, meaning you cannot extend multiple parent. However, a class can implement multiple interfaces. So this is a way to provide multiple inheritance-like behavior through multiple interfaces. Okay, and of course the implementation class has to implement all abstract methods of all those interfaces, otherwise compile error will occur. Okay, so this is an example where we are creating computer science student implementation class. So it could actually extend a single parent. So parent in this case is student. Okay, now it could actually implement multiple interfaces, however. So it could implement person interface, another interface, and third interface. Okay, the methods of these interfaces should be all implemented in this class, otherwise it's a compile error. Okay, all right. Let's do exercise 3. So here we are going to create another interface example which just contains a single abstract method. Okay, and then we are going to have this person interface to implement this is another interface. So it's actually implementing two interfaces. Person interface, you have to actually have a comma here, and another interface example. So this person interface has to implement all methods of this person interface and all methods in another interface example. So in this case, these two methods are coming from person interface, and this method implementation is for the interface example interface. Okay, and then you can actually change the main code. So here from person1 object we can call the measure intelligence method. Okay, and here we actually provide the name. Oh, okay, this is just the string. Okay, here we actually providing the name, and then we are calling measure intelligence method. Okay, that is actually from the the another interface. Okay, so here you can you can see whether it will actually generate the compile error or not, because measure interface method is defined in the newly added another interface, example interface, not in Persian interface. So you cannot, so in this case, Persian interface 1 is a type of Persian interface, right? So this variable, you can use the methods only defined in Persian interface, meaning you cannot call the method from the another interface, okay, which is this one. So you're going to experience a compile error, okay. And now if you actually assign Persian 1 to another interface example, then you should be able to call the method, only method that are defined in this interface, okay. All right, and you can build and run the application. And I'm going to ask you to do this for your own exercise as well. Add a third interface with the following method: compute first name length, okay, and make the person class to implement this third interface, and implementation of the compute first name returns the length of the first name, okay. So you can use the go to the string class and find out the how you can actually find the length of it, kind of things. So the computation of that is not that important. You can just return some hard-coded value. That's perfectly fine for this exercise, okay. And then you can modify the main.java to display that information, okay. So I'm gonna give you 15 minutes to do this exercise. So we talked about the fact that interfaces are not the part of the class hierarchy. So the interface cannot be a child class or a parent class of the regular class. However, interfaces themselves have inheritance relationship. So for example, let's say you have a Persian interface like this. You could define student interface that extends Persian interface, okay. So between interfaces you could have inheritance relationship, okay. So the student interface will inherit the abstract method from Persian interface, okay. So any implementation class that implement student interface has to implement both of these methods, do something as well as do extra something, okay. All right, so that's exercise 4. So let's try exercise 4. So here we have created student interface which extends Persian interface, and then it does have a single abstract method called the find school, okay. And then we are going to provide implementation class. So student is going to implement student interface. So what student has to implement is every abstract method of the student interface as well as its parent interface. So it has to implement both the methods from person interface as well as student interface, these two. Otherwise you are going to experience compile error, okay. And here basically we are calling get name and compute to wealth and find school. Yeah, so this is actually from the Persian interface, because student, take a look at this one. So you are actually assigning student object to student interface, right? Okay, so you should be able to invoke all methods of student interface, which includes the interface method that are defined in student interface as well as its parent interface, in this case Persian interface. So it should be able to call these methods from the Persian interface and these methods from its own, okay. And you can build and run the application. Okay, so I'm going to give you 10 minutes to do this exercise. Okay, so the next topic is rewriting interfaces. So let's talk about the problem that you might experience when you are rewriting an existing interface. So let's say you have defined an interface and you have provided an implementations, in fact several implementations. So the existing interface that you have is doIt. So this doIt has two methods, do something and do something else. Okay, so this interface has been implemented by other developers. Okay, now suppose later on you want to add another method to this interface. So you add it like did it work method to this interface. Okay, now the problem of this approach is that all the existing implementation classes will fail, okay, because they did not implement all abstract methods of this interface anymore, because they have not implemented this did it work method. Okay, so this is a problem. So how can we solve this problem? The solution is to create a child interface from existing interface. Okay, so this is in fact the reason the child interface, the concept has been provided in Java. So basically you are going to create a new child interface called the doIt plus, which extends existing doIt interface. Okay, so the new method will be added in this new interface, new child interface. So if you do this, and then you are going to actually use this new interface, a new child interface, for implementation that contains the implementation of this new method, while old implementation classes still should work because they actually implemented doIt, meaning the parent interface, not the new child interface. Okay, so this is actually pretty smart, the solution to the problem that we just talked about. Okay, so let's take a look at exercise 5. So exercise 5 is basically using the same example. So we have Persian interface. Oh, okay, so we are using Persian interface. And now if you try to add this new method, okay, and save the change, and then you are going to see immediately the Persian Java has a compiler error because it didn't implement all the methods defined in Persian interface. Okay, so that is basically for experimentation of the adding a new method in existing old interface. So the next step is we are going to actually take a solution approach rather than the approach that caused a problem. So we are going to leave the existing interface as it is, so remove the those two lines that you have added from Persian interface, and then you are going to create the child interface called the Persian interface another. Now this Persian interface another is not actually extending it yet. Okay, so you could actually implement this way. Yeah, so this is another approach. You can actually have, Persian another is actually implementing this interface and this interface. So we are taking advantage of multi-interface support in Java, so that's perfectly okay solution. Okay, the another solution is again using the child interface as we talked about. Okay, so here it's basically Persian another 2 extends Persian and implements Persian interface another. Okay, so that's perfectly okay solution. Okay. All right, so I'm going to give you I'll give you about 7 minutes to do this exercise. So this is reasonably straightforward, so hopefully there is no complication. Okay. Okay, so when to use an abstract class over interface. So this question was asked before. So, obviously you guys actually got the sense that the abstract class seems to be doing something similar to interface. I mean, the difference is that abstract class has some concrete implementation method along with the abstract method, while interface is completely made of abstract method. Okay. So the reason you might want to use abstract class over interface is that when you want to impose a common implementation code for all subclasses, that's the time you want to use abstract class. It basically reduces the duplication, right? Otherwise, the same code has to be implemented by multiple. So suppose if you use interface and all the implementation code is the same, then you're actually duplicating the code, right? Okay. So for abstract methods, the motivation is the same. So for concrete implementation is again, the guideline is that if they are going to be shared by all subclasses, use abstract class. If the implementations are all different, then you're going to use interface. Okay. All right. So a little bit of repeat. For abstract methods, the motivation is the same with the ones with interface. Okay. As far as abstract methods are concerned, yeah, the motivation is the same. To impose common behavior for all child classes without dictating how to implement it. So if you want to impose like a walk behavior, but each subclass provides different implementation, that's the time that you want to use abstract method. Okay. So remember, a concrete class can extend only one superclass, while the superclass is the form of concrete class or abstract class. Okay. All right, so that is the end of this interface and abstract the presentation and hands-on lab. So let me stop.